When a chemical reaction takes place, there are two kinds of molecules which are involved. One is called the substrate and the other is called the reagent. So let's assume an alkene is reacting with bromine to lead to the formation of a product which is basically dibromoethane. So here the substrate is this, whereas this is the reagent. And the substrate is basically the molecule which is involved in the new bond formation, whereas the reagent is the one which is helping or which is undergoing the reaction along with the substrate. So there are various types of attacking reagents which are present. Three of them, and there are three of them basically. So the first one is the free radical. We know that we already learned about free radicals in the intermediate, basically reactive intermediates, and these free radicals are also an attacking reagent. If you remember, when a free radical of carbon had formed, chlorine free radical was the one which reacted with the with methane to form the carbon free radical. Do check out the video to understand what I just said. The other two are nucleophiles and electrophiles. So let's start with electrophiles. Okay, I'll not put the number because that's misleading. So electrophiles and nucleophiles. So to be honest, when I was a student, I was unable to remember what a nucleophile was and what an electrophile was. As embarrassing as that sounds, one of my teachers actually gave me an idea as to how to remember it, and then I later found out that it was in the textbook. Anyways, an electrophile is electron loving. Okay, so electrophile is electron loving, whereas a nucleophile is obviously going to be nucleus loving. So if it is electron loving, it itself should possess a positive charge. So electrophiles have a positive charge, whereas a nucleophile, because it's nucleus loving, it will have a negative charge. So electrophile, electron loving, nucleophile, nucleus loving. Electrophile is having a positive charge, nucleophile has a negative charge. So electrophiles attract electrons. So they are either positively charged or they can be a neutral species, and these in turn have the tendency to attract electrons or a pair of electrons. So they are deficient of an electron pair in case of a positively charged, and in case of neutral species they have a tendency to attract a pair of electrons. So examples of positively charged electrophiles are H+, then Cl+, Br+, NO+, and even H3O+. All of these are electron deficient and they have a tendency to accept electrons, whereas neutral species examples include AlCl3, BF3SO3. So all of these, in case of AlCl3 and BF3, in these cases aluminium and boron do not have an octet, so they want to complete the octet, and that's why they act as an electrophile. So they're neutral species that act as an electrophile. But this does not mean all the positively charged ions are going to act as electrophiles. Examples like sodium Na+, it has 8 electrons in its octet. So because of that, it will tend to not act like an electrophile. Another example of this could be Ca2+. So these, despite having a charge, they cannot act as an electrophile because of their octet. Now, in case of nucleophiles, they can be electron rich and they will look for a electron deficient site. So they are nucleus loving. So these can also be negatively charged or they are neutral, but basically would like are attract the electron. So H minus hydronium ion, then X minus are halogens, OH minus these plus, and then you have Cn minus, and then R minus, that's a carbanion, RCOO minus, basically a carboxylic acid without a H, OR minus, SR minus. So all of these are negatively charged nucleophiles, and they will attract or they will look for an electron deficient site. In case of other neutral nucleophiles, examples include NH3, then RNH2, you see where this is going, R2NH, and R3N. Again you have H2O. Here we had hydronium ion, but H3O plus, and here we have H2O, and this is acting as the nucleophile. Then you have ROH and ROR. So alcohols and esters, all of these are acting as nucleophiles. Electrophiles and nucleophiles, these are very important. Electrophile is electron loving, nucleophile is nucleus loving. So they can, in case of electrophiles, they can be positively charged or they can be a neutral species which can accept a pair of electrons, whereas nucleophiles are negatively charged or neutral species which are looking for an electron deficient center. Now when a reaction takes place between an electrophile and a nucleophile, a bond will form, right? Because an electrophile is looking for a space which has a lot of electrons and electron rich space, whereas nucleophile is looking for an electron deficient space. So when a reaction takes place between an electrophile and a nucleophile, the nucleophile is going to donate its electrons to the electrophile and the bond is going to form. So the curved arrow is showing the movement of the electrons from the nucleophile to the electrophile. We'd also already learned about what the curved arrow denotes. And it basically, the electrophile is going to attack or rather accepts the electrons from the nucleophile, which is attacking an electron deficient space, which is the electrophile. So with that we complete the types of attacking reagents. Basically there are 4 different types of reactions. There are substitution, addition, elimination and rearrangement reactions. In the next chapter we will be discussing about all of these, because you'll be learning about alkanes. Basically we'll be learning about the hydrocarbons, and over there when we talk about the reactivity, you'll be learning about the various types of organic reactions. So with that we complete the fundamental concepts in organic reaction mechanisms. These are like the basis, or rather the basics for you to understand organic chemistry, and I mean in grade 12 you'll have more of it. You'll be learning about individual functional groups, and you'll be learning about the synthesis, reactivity, reaction mechanisms, all of that. And to understand all of that, it's better that you make sure that you understand the basics very well. So with that we complete fundamental concepts in organic reaction mechanisms. In the next video we will be starting to learn, or rather we'll be starting the discussion on the various methods of purification. So do check it out.